Unit 8, Day 3, Transformations. Let's get going. Graph the parent function y equals x squared in your calculator. Sketch the parent function and identify 3 points. If you want to plug these into your calculators, you can do that. I'm not going to do that, though, because we're probably going to have to do all of these without a calculator. So be prepared. Okay, if we're going to graph this parent function, let's use -1, 0, and 1. And in order to figure out our y values, you would just take each of these x values, substitute them here, and then square them. So we took -1, substituted it for x, and then squared it. That would give us 1. Here we'd have 0. Here we'd have 1 again. If we were to plot that, it would probably look like that, but it would be continuous. So I'm going to go ahead and make it continuous. That is what a parabola looks like. Looking at example A, graph the following transformations of the parent function in your calculator. So here we have quadratics, also quadratics, but there are transformations. If you have anything in parentheses, this is going to be a horizontal shift, left or right, and it's going to be opposite of what you think it would be. So here we're going right. Nope, it's going opposite, sorry. Left 3. Here we're going right 3. Notice that we have a +3 and a -3, but they're not inside parentheses. So these are going to be transformations that are going to impact our y values, and meaning vertical, we're going up or down in this case. And it's going to be exactly what you think. So here we would be going up 3. And here we would be going down 3. What rule could we use for translations for all functions? Well, as you just noticed, if it's in parentheses, that's left or right, and it's opposite of what you think it would be. And if it's not in parentheses, that's going to be a change in y, up or down. And it's going to be exactly what you think it would be. So up 3 or down 3. So you can write that down if you want to. Sum it up however you would like. I'm going to just move on to the next section. Okay, reflections. Graph the following parent functions in your calculator. Sketch the parent function and identify 3 points. Let's see, for our square root function, I'm going to use x values of 0, 1, and 4, because we're dealing with the square root. So I'm going to pick perfect squares. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. If you were to plot that and then continue it on, it would look something kind of like that. Over here, we have an exponential function. I'm going to plug in, I'm going to use 0, 1, and 2. If we plug in a 0 here for x, 2 to the 0 power, anything to the 0 power, is 1. Plug in a 1 for x, 2 to the first power is 2. Plug in a 2 for x, 2 to the second power is 4. Now these are going to have a horizontal asymptote, and then it's going to shoot up from there. So that's what exponential functions look like. Here we have a reflection over the x-axis, reflection over x-axis. And then here, notice that we now have a negative that is inside with the x. Therefore, we're going to have a reflection over the y-axis. Now, if you'll notice for G and H, we don't have a set of parentheses. We don't have roots. We have exponential functions here, but we're going to treat them pretty much the same way as if they were parentheses or roots. So here we have a negative that is attached to that x. Therefore, we're going to have a reflection over the y-axis. We have a negative that is not attached to the x. So this is a reflection over x-axis. What rule could we use for the reflections? Well, we just went over it. Feel free to summarize that however you would like. Now let's deal with some stretches and compressions. Using the parent function y equals x squared, graph the following in your calculator, which I'm not going to do. And then what happened? All right, notice we have a 3 that is outside of the parentheses. This is going to be a stretch that is going to impact our y values. So we're going to have a vertical stretch of 3. Notice now we have a 3 that is inside the parentheses with the x. Therefore, we are going to have a horizontal, what do you think? It's not going to be a stretch, actually. It's going to be a compression. Of 1/3. What? Remember, anything that is inside with the x is opposite of what you think it would be. These are good examples here. Here, you would think, don't we need to go right 3? No, we need to go left 3. Here, you might be thinking, shouldn't we go left 3? No, we actually have to go right 3. So anything that is inside parentheses that is impacting the x values, it's actually going to be opposite of what you would think, which is why we're not actually going to multiply our x values by 3. We're going to divide them by 3 or multiply them by 1/3. Here we have a compression of 1/3. Here we have 1/3 times x. We're inside the parentheses with the x. So it's actually going to be what opposite of what you think it would be. We're going to have a stretch of 3. What rule could be used for stretches and compressions for all functions? Well, we just covered it. Feel free to summarize that however you would like. Okay, looking at M, N, and O, be very careful. Notice that we have some additional stuff in here with our x. We have a negative x plus 3. Here we have a 2x plus 6. Here we have a negative 2x plus 8. So you have to factor some things out first before we can determine what are our transformations here. So since we have a negative in front of x, we want to factor that out. And when we factor out that negative, that leaves us with x minus 3. So here's what we now have. We have a reflection over the y-axis. And we have a horizontal shift. We are going right 3 spaces. If we're in, I'm just going to section that off a little bit. We just need to factor out what's in the parentheses. So let's factor out the 2. That would leave us with x plus 3. Now I'm going to create this set of parentheses that surrounds all that. And don't forget that we're squaring the problem. And now let's figure out what our transformations are. That 2 that we had to factor away from the x is still inside parentheses with the x. So it's going to be opposite what we think it would be. We're not going to have a stretch of 2. We're actually going to have a compression of 1/2. And then we will be going left 3. Okay. So for example, O, let's start by factoring out the negative 2, leaving us with x minus 4. Looks like we're going to have a reflection over the y-axis. We have another compression of 1/2. And we will be shifting to the right 4 spaces. And here's a little guide that just goes over everything we just covered. Extra practice. Identify the transformation of the parent function f of x below. I'm going to start filling these out silently. How about you give it a shot? Maybe pause the video. And then once you fill them in, play the video and see if you got them right. And now we're on the last side of our notes. Use the graph at the right as your parent function. Identify the transformations and graph the examples below. Reminder, transformations should be completed by order of operations. Okay, let's get going. Notice here we have a compression, a vertical compression of 1/2. Then we are shifting right. Now here's how we would build a transformation table. We are shifting to the right 1. We're taking our x values and then adding 1 to them. So we're going to use x plus 1 to help us with this column here. Then we're having a vertical compression of 1/2. We are taking our y values and then we're going to multiply them by 1/2. So 1/2 y. And then we're going to take all the x values from this column here, substitute them for x, and then add 1. So I would take -4 from this parent table, plug it in here, and then do the math. -4 plus 1 is -3. Now take -2 and substitute it. -2 plus 1 is -1. Take take 0 and plug it in. 0 plus 1 is 1. Take 2, plug it in. 2 plus 1 is 3. Take 3, plug it in for x. 3 plus 1 is 4. Now we're going to take all of our y values, plug them in here for y, and then multiply by 1/2, or divide them by 2. So if I took -2, plugged it in here, -2 times 1/2, or -2 divided by 2 is -1. Take 0, plug it in here, 0 times 1/2, 0. Take 2, plug it in, 2 times 1/2, 1. Take 2, plug it in. Take -1, plug it in, -1/2. And then we start plotting and graphing. Example 1. All right, let's take a look at example 2. Well, we're going to have a stretch of 2, vertical stretch of 2. Here we have a -x, so we're going to have a reflection over the y axis, and then we're going up 3. So let's start with our x transformation tables. We're just taking our x values and we're multiplying by a -1, or we're negating them, however you want to think about it. So -x We're stretching by 2. So we want to multiply our y values by 2, and then we're going to go up 3. Now we're going to take all of our x values here, substitute them for x, and then multiply them by negative. So pretty much all these signs are going to flip, because -4, -4 times the negative in front, -1, would be +4. So all the signs just flip here. Make sure I did that right. Good. Okay, now we're going to take all of our y values, substitute them in here for y. So take -2, substitute it in here. Now we have to take that -2 and multiply it by 2. -2 times 2 is -4. Now we need to add 3 to that. -4 plus 3 is -1. Just follow those order of operations for the rest of these numbers. And now we can plot. Example 3, we're going to have a flexion over the x-axis. That's what that negative in front is. We're going to have a vertical compression 1/2. We're going to have a horizontal compression also of 1/2. Remember, whatever's in there with the x, it's opposite of what you think it would be. And then we are going to go down 3. Now here's how we would build our transformation tables. Looking at the x values first, horizontal. Looks like we're going to take our x values and multiply them by 1/2 or divide them by 2. I'm just going to do x over 2. For our y values, let's start with the negative first, the reflection, then our compression, then y, and we're going to shift down 3. -1/2 y minus 3. And take all your x values, substitute them here and do the math. Take all your y values, substitute them here, do the math. I'm going to start doing that. You do it as well. Let's see if we get the same thing. Now I can plot and graph.